Hi, everyone. How are we doing here today? What an absolute pleasure to be here, joined by you. As Marie mentioned, there is a Q&A widget. Use it. We'll see if we will answer them ad hoc or keep them at the end. It depends on the question and the train of thought, of course. Now, I know how these webinars work, ladies and gentlemen. Most of you will watch this on demand. So if I welcome you, I should say, dear audience member of the future, welcome, enjoy this session, and thanks for checking it out. But to those brave souls who have the dedication and the tenacity to watch it live, an extra thank you. So if you look at the title, you'll see that it's called How Artifact Caching and Virtual Registries Can Supercharge Your CDN. So what is that all about? So let's start with this word, artifact. And we'll do artifact caching. And we'll do that through a virtual registry. A lot of buzzwords already, and we'll use that to supercharge CI/CD. Whew, it's quite a mouthful. So let's break it down for a second. What is an artifact? Well, talking to platform engineers here, I guess I'm preaching to the converted. You probably know what it is. And yet I will still explain it because you can never assume, right? An artifact is a dependency or a product of the software development process. And it helps you define and design and build and test and maintain a system. That's how I would define an artifact. Now, it's quite an abstract term, so let me give you a couple of examples. As you can see on screen, there's a bunch of logos here of tools you may know and you may use, and they're categorized not really in a formal way, but you can see operating system packages like Alpine, RPM, Debian. You can see the different programming languages like Go or JavaScript, represented by the NPM one, Cargo for Rust, PHP, Java, Ruby, you name it. And then a whole bunch of other runtime dependencies and configuration as code and orchestration as code tools. So that's what we're going to talk about, the different ones. It doesn't really matter to me which one it is. And what we'll do with it is caching. Now, what is caching? You know what caching is. Still, I will define it. It is storing a pre-computed result for later use. And when you use it later, it will be faster because it's aimed at reducing the computational and network pressure. Maria, I'm going to need your help to prove the point. So caching, we all know the value, but I'm going to show it for real, in real life, what it is. So here we go, Maria. I'm going to need your participation. What is 5 times 3 times 4?
Oh my God, this is a math lesson. 60.
It took you 4.5 to 5 seconds, which is fair. 60. Let me ask you again, what's 5 times 3 times 4?
60.
That's 3 seconds. That's faster. One more time. What's 5 times 3 times 4?
60.
See, that is the point I'm trying to prove. That is caching for you, ladies and gentlemen. It is storing something that otherwise takes a little bit of time, but keeping it, memorizing the result rather than recomputing it every time. And that is what's going to make things a lot faster. And the caching will happen in what we call a virtual registry. So what's a virtual registry? It's a virtual layer that abstracts a direct access to those artifact registries. And then we get to the registry itself. What is a registry? Well, we thought about it with a bunch of colleagues because people always confuse registries with repositories. But a registry is a collection of repositories. And in our case, artifact repositories. So I have a nice little diagram that illustrates that. You can see a registry. A registry has multiple repositories, and those repositories contain the artifacts. Now, a virtual registry is an abstract layer in front of it that routes and caches and does other things to improve the situation. And improving the situation means supercharging your CI/CD, because we all know at scale, slow CI/CD pipelines can really add friction and in general just reduce efficiency all around. And that's what a virtual registry will do. Virtual registries have specific capabilities. Because it is a sort of a proxy in front of your actual registries, it could perform caching, it will perform routing, it has security capabilities, observability capabilities, you name it. But for all intents and purposes, today we'll be approaching it from a caching perspective, primarily. All right, that's the intro, folks. I hope you're settled comfortably, you have a drink, maybe some popcorn on hand, because we're about to get into it. First things first, hi, my name is Thijs. Pleasure again to have you. Thijs, I'm quite used to having to justify my name and the pronunciation of my name. Thijs is a Dutch name. I'm a Dutch-speaking Belgian, and I hold the title of the tech evangelist at Varnish Software. I know, folks, that term, that title, I had to justify it a lot. It's quite a lot. And the picture certainly doesn't help. But if I have to summarize what I do a lot of outreach. Webinars like these, a lot of in-person, on-stage presentations, content creation. I write blog posts. I'm even an author of 2 books that you could buy online. And I do this for Varnish Software. And Varnish Software, some of you will know us, others don't. So allow me to explain what it exactly is that we do. So we are a company that builds software-defined web acceleration and content delivery solutions with a very strong emphasis on software-defined. That means you can host it wherever you want. That could be on-prem on a bare metal server, or with a hosting company who offers virtual machines. It could be in the cloud at various cloud platforms, or even with the big hyperscalers. You could run it in a Docker container or orchestrate it in a cloud-native framework like, for example, Kubernetes. And those workloads that you host on it could be anything that speaks HTTP. And that's quite a varied set of use cases. The origin use case of whatever we do is always websites, right? That's what HTTP was originally invented for. Websites, applications, APIs. But later on also video streaming platforms, software acceleration, and any type of file that is transferred over HTTP. And the use case, or the pattern rather, of how we apply these caches, because you know there's tons of caches out there in the world. As they say, it's turtles all the way down. Well, the type of caching I'm going to talk about and that we offer is under the form of a reverse caching proxy. I used a little bit of a logo here and a text calling it Varnish, but I'm not just representing our company, I'm also representing an entire industry, meaning this could be whatever technology that you want that supports HTTP and thus caching. Virtual registries aren't, we don't have the monopoly on them, so to speak, but we are really good at accelerating them. And by positioning ourselves as a reverse caching proxy between the user and the server, we're in a unique position to offer 2 main benefits. It's quality of service and quality of experience. Now, quality of service is simple. By caching the responses coming from the server and handling all the requests from the user, we're offloading the pressure from that server, hence the dotted lines, of course. We ensure that all these requests don't always end up on the server that have to recompute it. Our little party trick with Maria, the 5 times 3 times 4, that doesn't always have to happen. In the end, that cache will store the result, store the 60. That's quality of service, ensuring that the service is fast and stays up and running. However, there is a secondary benefit here, and that's quality of experience. In most of the examples, the cache is pretty close to the server. But if you push the cache closer to the user, you're closing the gap and reducing potential network latency, hence quality of experience. But I do want to remind you, while this is about CI/CD and we can cache a lot of different things, we can in fact cache all the things. If there's one takeaway, one major takeaway, we can cache all the things. And that comes with the good and the bad. I mean, being able to cache everything, not everyone has the imagination or the capabilities of extrapolating that to a specific use case. So allow me to explain what it is about. And before we do that, why does this all the things little figurine have bunny ears? Well, that's mascot. This is the Varnish bunny. But enough with the party tricks. And you may ask yourself, wasn't it supposed to be about CI/CD pipelines? And how is this, all of this related to artifacts? Well, let me give you a very brief history lesson of how we got there. Speaking about web acceleration and using the HTTP protocol with caching, we first saw a big on-ramp onto the solutions we offer in 2010. Most of it was websites, web applications, APIs. That first wave started in 2010. It doesn't mean the wave ended. The wave is still going on. It's still very much part of the essential tools that we accelerate, and it's an important use case. But in 2010, that was all the rage. We did see a shift in the adoption of HTTP, and the Netflix effects had a true impact. All of a sudden, people didn't want to watch TV linearly anymore. They needed some type of streaming platform. So everyone, whether you were a media company or a telco or a broadcaster, you needed some type of OTT streaming. And that was the majority of the data on the internet. It was video. And I think still to this day, a lot of it is video. So there was a need for acceleration, and that's where we dove in. What we're seeing now, and with now, I don't mean 2025, but what started in 2024, was an interesting situation. Whereas prior to that, we were used to being able to deal with a lot of clients, like thousands or tens of thousands of people, all going for the same content. And the acceleration layer really benefited that. But now we're seeing organizations looking more inward. Instead of having to deal with tens of thousands of users, they're dealing maybe with hundreds of CI workers who are extremely demanding and for which latency is a very sensitive topic. So all of a sudden, we see a lot of organizations struggling with the delivery of their dependencies, dependency resolution in CI/CD pipelines. So for builds, for deployments, also for developers, and also for just data in general. If it speaks HTTP and it's part of your delivery workflow, it could probably need some acceleration. So whereas this diagram used to be the standard way of explaining what we do, in the context of today, I'm going to switch it up to this one. See the difference? We're going to switch from here to there, where the server used to be a generic web server hosting a web application. Now it's a very specialized type of registry. And where the client used to be a lot of users, it's a specific set of CI and CD workers, both regular ones or, looking at the future, agentic ones. Those need acceleration. And to drop some numbers on you, the average CI/CD pipeline spends between 20 or 40% on dependency downloads, right? That's a lot, right? Dependency downloads 20 to 40%. We probably must find a solution to accelerate that. So we cache artifacts. And why do we do it? Well, first of all, to tackle that speed problem. Having faster delivery makes things better. If slow dependency downloads prevent you from doing those builds or going live, it's organizational friction. But it's not only about the raw horsepower. At scale, users and organizations want predictable builds and predictable deployments. So ensuring that these artifacts that are downloaded could be scaled is even more important than the raw speed for a lot of organizations. That's on the performance and scalability side. On the other end of the spectrum, it's about cost and risk. Egress fees are a real thing. You could probably relate to that. Hosting something in the cloud is very flexible. We love the cloud. However, they charge you for the gigabytes transferred. And a lot of organizations are really struggling to keep that affordable, especially as they grow. Also, resilience is important. What we call offline mode. When things start to fail, and they do, and we'll get to that in a second, you need to ensure that you can continue your work as a developer or as a platform engineer to facilitate builds and deployments. And just let me remind you that all of this friction compounds at scale. The more builds you have, the more deployments you do, the more deployment targets you have, and the more developers you onboard, the more pain you'll feel. It'll grow. And I think this, and I'll keep that slide on for a couple of seconds, is the perfect example. I couldn't have found a better XKCD cartoon to illustrate the situation. As it says, the number one reason for programmers to legitimately slack off when they do crazy stuff is to say, hey, don't worry about it, we're compiling. And then the manager says, carry on. While compiling is a big part of the CI/CD stack, primarily CI, right, doing those builds, you can easily solve that by putting in bigger machines. The compilation task is not the difficult one. An equivalent of this cartoon could be downloading artifacts, and the manager would say, oh yeah, carry on. So we need to accelerate it. So you've probably seen this diagram already. Let's make it a lot more practical and choose one specific type of artifacts that really lends itself to caching and that a lot of people use. So instead of using this abstract registry, let's make it a Docker registry. Right, I'll focus a bit on Docker because it's an interesting use case, but please do use your imagination. There's different type of artifacts that you may need in your organization that are not Docker. But let's start with Docker. When you do a Docker pull, maybe Docker pull Ubuntu, behind the scenes, it uses HTTP. Not maybe directly in the client, but the runtime, the Docker program that runs will perform HTTP calls. And those HTTP calls can be slow, depending on the artifacts registry that you connect to, on the network situation, maybe your system as well. And it's a very good candidate for caching. And allow me to prove that, why it is so good for caching. So imagine you're doing a Docker pull on your system of the standard Node.js public image. You pull it, Docker pull node, it downloads to your system. Then you can run Docker save, if you want, of that node image and redirect the output to a tar file, node.tar. You can then extract the tar file and do a tree command of what has been extracted. And this is what you'll see. So if you ask me, what is a Docker image? What composes a Docker image? Here's your answer. So straight out of the gate at the bottom, you can see metadata under the form of an index.json and a manifest and an OCI layout file. But the actual Docker image is a collection of files, binary files, that are a bit easy to spot, but they are in the blobs SHA-256 folder, and their name is actually the checksum of the content, which is kind of interesting. So you see multiple layers here. If you look into the manifest.json file, you can see that one of those layers is assigned for configuration. There is some metadata saying that whatever you're seeing here in terms of layers actually represents the Node.js base image, and it is the latest tag. And then you see all the layers. Pretty cool. However, that is on the storage side. When you pull them in, these are the URLs that will be called behind the scenes. You might not be aware of this, but when you do a Docker pull, the first thing it will do is it will connect to a V2 endpoint of that registry. It is an authentication endpoint. It's also sort of a landing page to know what's what. Even for public images that don't require authentication, this V2 endpoint will still present you with an authorization endpoint where you can get a token without authenticating. So that means all the subsequent requests have some sort of token that is used, even for public images. And using that token, then you can go to the next URL. So if you're getting the latest tag of the Node.js image, this is what your Docker system will do. It will connect to V2, library, node, manifest, latest. And in that manifest file, as you've seen before, all the other layers are mentioned. And then all those layers are pulled in. These are the image layers. And they are immutable. And they're also content addressed. As I've said earlier, the name of the file is actually the SHA-256 hash, the checksum. So that means if one byte in the file changes, the file name will be different because it's a different hash. That makes it super easy to cache. You can store these in the cache without a problem for nearly infinite amount of time. Because it is important to know that the collection of these files that you just seen is, and I've taken a screenshot of the Node.js or Node.js image on the Docker Hub, it is 415.8 megabytes in size. That's quite big actually, and it's been downloaded more than 1 billion times. So it's worth positioning it in a cache and putting it as close as possible to the end user for the sake of acceleration. And this is what that would look like if you would apply what we call a virtual registry with artifact caching capabilities. In terms of positioning, it is much closer to the consumer than to the producer of those artifacts. So what we'll do with a virtual registry is we'll position that as close as possible to our clients. These could be CI workers, like a local runner of GitHub Actions, or GitHub Actions in the cloud itself, or GitLab, or Circle CI, or it could be a CD worker that does the deployments like Argo CD, or it could just be a developer sitting at home or in the office pulling in those registries. And the actual registries are then categorized with build dependencies, runtime packages. You recognize the logos, right? Or even, surprise, 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 Git repositories. Did you know that you can cache Git repositories? And sometimes it is needed. We have clients who do that to make Git fetches, Git clones a lot faster. And you can do that for those public images. And you can host that virtual registry as close as you want it, probably in a private environment. But what's the problem? Why would you need to accelerate that? Isn't it in the cloud? Isn't it SaaS? Doesn't it work out the box? It does, most of the times, in most situations. And the thing you'll run into quite quickly, especially at scale, is the rate limits that these registries impose on you. I mean, you could probably relate to that. And I asked the question when I did different presentations, even on stage, by interacting with the audience. And I asked, who has ever experienced Docker Hub rate limits? I had a bunch of people raising their hands. And maybe you can relate to that as well. So this is not me criticizing that platform, because if you offer a thing of that magnitude at such scale, you need to keep the platform afloat under extreme pressure. And that's where rate limits come in. If you download the Node.js image 1 billion times and it's 415 megabytes, I mean, that's not an easy task. So I get it. There's rate limits. But we've also seen that not all artifact registries are created equal. We've had clients who, for some reason, sometimes contractual, commercial, or operational, switched from one vendor to the other, and they noticed it was significantly slower. So for them, caching makes a lot of sense. But in terms of resilience and the offline mode, I already hinted, cloud outages are the main culprit. Which is interesting timing, right? We had a bunch of cloud outages. I won't name the platforms and the CDN vendors. There's no need to shame them. Running these platforms is a complicated business. Outages can happen. But the problem is that we as users tend to forget that. We sometimes forget that these things can go offline. It goes in waves. Now we're fully aware because of the coverage in the media that the big boys went offline. So you need some sort of resiliency where you can make sure that all the artifacts that you need for your day-to-day are there, because otherwise your developers, but also your pipelines aren't doing anything. And in the end, why would you also cache registries of the public nature? Well, to reduce egress charges. If you have a platform hosted in the cloud that bills you per gigabyte transferred, maybe it's better to have a copy close to where you deploy and close to where you build. So remember this one? This is a way of using a virtual registry to cache these public images. Let's switch it up a bit. Let's introduce another piece of technology that a lot of big organizations use. At the private side of the equation, maybe within the office or in a private environment, you will probably see a universal repository manager. And these are pieces of software that are particularly popular in the enterprise setting. A lot of our clients use them. And these are really good specialized tools. The biggest one in that segment is arguably JFrog Artifactory. But as you can see, there's competitors out there like Cloudsmith, Sonatype Nexus, and in some way, Harbor also competes with that. What they do is they provide a way of having a similar experience with the toolkit you have for your programming language or your Docker images, your Helm charts, your operating system packages, of having this workflow but in a private environment. And they're also a layer that can host all these different types of artifacts. And they have integrated access control policies and security capabilities, and it's all nicely integrated. But we see that a lot of organizations struggle with them. Most of the clients we have that contact us that need some sort of virtual registry do it because they're struggling with these repository managers. So what's the problem with them? Again, for the record, disclaimer, this is not me criticizing these organizations. Their products are really good. Otherwise, the organizations wouldn't get them. But at a certain scale, if you're big enough, you'll run into some sort of issue. Latency being the primary one. Especially on the self-hosted systems. If you're hosting it yourself, you have to care about infrastructure, you have to spin things up. And if your environment grows and your organization grows, well, those systems don't always scale along. So dealing with latency is the #1 factor. It's hard to scale. Now, a lot of these vendors also have a SaaS product, and then it changes a bit. Then it goes from difficulty scaling it to, oh my God, we're getting billed so much for egress because we're pulling in all these resources. Well, regardless, you'll have to deal with it. You have to deal with egress charges, you have to deal with infrastructure costs, and a big one is license costs. The upsells to the next one to deal with the scale are sometimes quite significant. And I know I'm looking at an intelligent audience right here, either the people who watch this live or on demand, and you may ask yourself the question, hey, Thijs, it's a nice pitch, but why don't you use a CDN? Well, I'm not stopping you from using a CDN. And if your situation is the problems you have, the challenges you're faced are solved through a CDN, by all means, use CDNs. I'm not here to criticize CDNs. They're literally the giants that carry the world. And without CDNs, there would be no internet as we know it. If you can use it in a functional way, a fast way, a scalable way, and an affordable way, then go CDN. However, we notice that CDNs aren't always the answer. And coverage is the big one. If we're trying to keep latency low and your deployment targets, your developers, your CI runners aren't close enough to where your CDN has coverage, then all of it goes out the window. Coverage is a big one. And primarily these big CDNs and also the hyperscalers and the cloud platforms are in these premium markets. If you're not in a premium market, you're out of luck. Also, egress, again. The business model of a CDN revolves around having some metric of measurement, and egress is the way. So the way you pay for a CDN is by paying for egress. And the final piece of the puzzle is that CDNs aren't always equipped to handle the authentication bit. And if they are Probably they're storing duplicates of the artifacts for every user, which totally defies the purpose. So the name of the game, ladies and gentlemen, is hyper-localization. It's not just localization, it's hyper-localization. It's being as close as possible to the consumer. Only then do you get the full value out of the artifact caching capability of a virtual registry. Let me give you an example. It's something I ran, I think, 2 weeks ago. I was in a public space and I wanted to download the Node.js image. And I added the time command in front of it to measure it. And here's what happened. It took me 51 seconds to get a hold of it. Now, of course, the timing isn't, the heavy lifting isn't really done by the Docker client. The heavy lifting is done by the actual Docker runtime. So the timing is or the way the timing is computed might seem a bit weird, but it took, all in all, 51 seconds to get the image. And I think about 12 seconds or 11 seconds of that was extracting the stuff we got down. So the rest of it was downloading. When I installed a virtual registry on my system, I deployed it via Docker and exposed the ports so that it was available on localhost. So the .localhost domain that is available on my Mac resolves it to 127.0.0.1. And when you want to get the node image of something with a prefix, you have to add library in front of it. And I ran it, and it was slightly faster, but because it was a cache miss, it didn't really add that much value. Then I removed the image again and ran it again on a hot cache, and it only took 12 seconds to do the same thing, of which I'm pretty sure of the 12.113, the full 12 seconds was extraction, and this 113 or less is network. Because remember, I have a copy of it on my laptop. So it's pretty nice, right? Going from 51 seconds all the way to 12. That's just one example. At scale, it can compound even more. But ladies and gentlemen, we're not always doing this on our laptop. There is a CI/CD element to it. So I had to pick a CI/CD vendor. And I kind of like GitHub Actions, and a lot of people are using it these days. So here's an example of using this Docker image within GitHub Actions. When you do a Docker build of your custom image, it's called app image, you probably need to pull in a base image. So at that time, you will need a Docker file. And that Docker file, remember this guy? Node latest, you have to pull it in, 415 megabytes. And at scale, or if you face rate limits, or if your private registry is overloaded, that will take a lot of time. So here's a way out of it. Here's a solution. What if you apply this hyper-localization mindset and take advantage of GitHub Actions self-hosted runners? You can actually deploy those self-hosted runners wherever you want. And in one of the test cases, we actually deployed it in the same Kubernetes cluster, in a different namespace, where we eventually are going to deploy the Docker image and the Helm chart and the packaged application. As you can see, there's different action runner sets running. And that means switching up your configuration, your GitHub Actions configuration. Instead of using Ubuntu latest as the runner, we're going to name it to our action runner set. So that means while the management and the execution initially still happens on GitHub, it gets passed on to the local runner that runs in the same Kubernetes cluster. So in terms of latency, we'll keep that to a minimum. But the secret sauce, as you can see at the bottom, is pushing and pulling from within the Kubernetes cluster. So we retag the image, and we get it from a varnish.default svc cluster.local endpoint. And for those of you who know Kubernetes, know this type of structure. This is an internal DNS name for a service called Varnish that we expose in Kubernetes that is hosted on the default namespace. So what we're in fact doing is, instead of pulling it from the outside, making sure that where the deployment happens and where the CI runner is, the virtual registry is as well. And you can imagine that the latency is as low as it can get, because you're not going to the internet. You're not even accessing the local network. You're staying within the cluster. And that is where the real value is. And you can retag the base image where you're going to pull that from as well. And you can even retag the image that you're pulling in your Helm chart for deployment, so that it's not only the CI part, but also the CD part that gets accelerated. And you can go from sometimes even minutes of waiting to get certain artifacts into milliseconds. If you don't want to retag, I'm pretty sure there's other ways of doing it in Docker. Here's an example when you use pure Docker under the hood, is you can register a registry mirror, as it call it, and that's just an endpoint to a pull-through cache. That's how you can do it. But enough with the Docker for now. I'd like to remind you that it's not only about Docker. I mean, there's plenty of other artifacts. Yes, Docker is a good one. You can do a Docker pull on that environment, but you can also use it, for example, for NPM packages. If you want to install the Express package and you want to pull it from a virtual registry, you can use the -- registry option and point it to the host name of your virtual registry. For Go, it's similar. Use a Go proxy environment variable, set the endpoint. And even for OCI, if you want to do a Helm chart pull and pull it through a pull-through cache like a virtual registry, it happens there. So hyper-localization will help you to get there. In the examples, you can see I'm using .localhost. For simple tests that works in production, you'll use something more elaborate. And speaking of elaborate, there's no such thing as hosting a single artifact cache. You will position them exactly where you need them. So in this example, or the earlier example, we have the artifact cache within the same Kubernetes cluster where the application is and the CI/CD runners are. Great. But maybe your developers aren't close to that location. Maybe your developers are remote, in an office or at home in a specific region. You need to put artifact caches there as well. That is extremely important, to position them exactly where they're needed. And these artifact caches together could be considered the virtual registry. I mean, how does an artifact cache differ from a virtual registry? It's a lot of buzzword bingo, I'm assuming. Well, I would say artifact caching is a capability of a virtual registry, as you could see, among others, right? We can do routing as well on this virtual registry. We could perform security. We can have pretty intricate observability tasks that give you complete insight on the behavior of your CI/CD pipelines and your developers when it comes to artifacts. The good news is I'll talk more about the other non-caching capabilities in another webinar. We have an upcoming webinar, probably in January, right, Maria? So we'll talk about the other capabilities there. But let's talk about some more pressing matters, is the private packages. How do you deal with that? Because that adds complexity. And I already mentioned that CDNs might not be equipped to handle that so intricately. So let me explain the flow. Here we go. A CI/CD pipeline, or developer, could be a developer, does an authenticated request. The artifact cache, the virtual registry, gets it and needs to validate whether this user is allowed to have access to that resource using the credentials passed along. We are not going to reinvent the wheel or implement custom access control logic. We actually forwarded the token, the authorization credentials to the registry, to the artifact registry. We're piggybacking on top of it. And if it's not allowed, we just deny access. If the user is allowed access based on the access policies in the artifact registry, we cache the authorization separately. That's a little bit of the secret sauce. I'm not going to get too much into the details, but what we do is a lightweight sort of pre-flight call with the authorization in it. We do that under the form of an HTTP GET call, so we don't need to receive any payload, and we store it upon success. And we store the actual artifact separately. So that means all the subsequent requests, even the authorizations, could be validated from the cache for a given point in time. So if we need to summarize how we deal with private images, authorizations are cached on a per user basis, but are so lightweight that they hardly contain any data. But the artifacts themselves that they represent are only stored and cached once. And so you can use the cached authorizations to grant access to an artifact that is only cached once. And that's where the efficiency lies. And another hidden surprise that I noticed when we talk about efficiency, and we need to get back to Docker, is what is an artifact? Well, it could be a collection of many files. But as Docker images have multiple layers and inherit from other images, you could be doing yourself a massive favor by caching one image and inadvertently adding or caching layers of another image. Take, for example, the node latest. I color-coded it for your convenience. If you look at the first 4 layers, they are identical to the build pack depths bookworm. That's because node inherits from the build pack depths bookworm image. So if you pull in node latest, you already have build pack depths in there. So if you would need it for another image, or to build a custom image on top of it, it is already stored in the cache. You don't need to fetch it. So we have caching not even across user, but across images as well. And that brings a level of efficiency. So let me throw some numbers at you. Maybe you want to hear how a lot of organizations tackle this. I won't be able to name the organizations for contractual reasons, of course, but I am capable of throwing around some numbers. So there's this big global financial institution. You've probably heard of them, can't mention them. And they say that nearly 50% of their CI latency came from artifact pools alone. And the backend CPUs, meaning those registries, sat at 100% all the time. So they needed some sort of offloading. Another client of ours, which represents a global SaaS platform, it's a brand, it's well known in the industry, says that 94% of its network traffic came from repeated artifact downloads across teams. Let me quantify that. That 94% represents 6.5 petabytes. We managed to offload that 94% and save him 6.5 petabytes of egress, which justified the use of the virtual registry alone. Another major media service, also extremely well known in the industry, says that by using a virtual registry, 99% of their artifact requests never reach the origins. They use it for a variety of artifacts, but they also use it to accelerate Git clones. And they noticed that their Git clones went 3 times faster. And because of the offline mode and the flexibility in routing, they can do rather complicated migrations that were quite critical and that would otherwise result in temporary build failures. It was seamless. Those build failures were gone. Is it part of the way we approach things? Yes. But in general, if you apply any kind of virtual registry, ours or other ones, you will have probably the same benefits. And here's the last use case. Here's a research institution that, apart from what you see on the slide, also does gigabyte-sized Docker images that they need to move. And sometimes, if number crunching needs to happen on demand, they need to deploy those images to thousands of on-demand servers that spin up. So that alone is a big problem. But they also use NuGet. Now, for those of you who don't use or know NuGet, NuGet is the package manager for .NET. And they noticed by downloading NuGet packages from a virtual registry that their restore times fell from 3 minutes to just 1 minute, and that the latency cut was more than 60%, and the pressure on the backend servers dropped by 70%. So from a more business and value proposition perspective, it provides tremendous value. And I'm not afraid to say that I was surprised, like last year, hearing about all these use cases. I'm a guy who grew up accelerating websites and APIs. I interact with developers. Then I noticed that I had to interact with people running video platforms. And now I'm dealing with DevOps, SRE, and platform engineers at a different scale and from a different perspective, looking inward, not outward. Let's put a platform engineering spin on this. So as platform engineers, I would strongly advise you to make it a platform capability. It is important. I went, as Marie indicated, I went to the platform Con Live Day in Paris, and I heard a lot of interesting stories from organizations who needed to build their own platforms for obvious reasons, efficiency, cognitive load, just streamlining it. And if CI/CD is part of your story, if artifacts are part of your story, which in most cases they are, right? Make it a platform capability, integrate it into the platform from the start, and place the caches close to the workloads. I've repeated this over and over. I shouldn't repeat it anymore. Also, measure what matters. In the next webinar, I'll talk a lot about observability. Being able to measure from that singular endpoint where governance is simplified, right? It's that abstract layer. You can see what everyone is trying to do. But I think it will be a lot harder to measure that usage on the individual registries. Now you have complete insight. You can also apply security policies and manage the freshness of these resources. It's all in all very simple. And speaking of simple, this is the last part of this webinar, is we figured out, we've been telling you we can accelerate all the things, but sometimes people want something very practical. So we built something very practical that I would like to introduce. We've made announcements before, but we created this product optimized for artifact caching, and we call it Orca. Of course, the symbolisms are there, right? Orca, it fits the maritime team of Docker and Kubernetes and what have you. It's not the whale of Docker. It's an Orca. But Orca, it's not really an acronym, but it does contain some keywords: objects, registries, caching, artifacts, acceleration, you name it. What it actually is, it's what we call a virtual registry manager. It's sort of a pull-through cache, as you've seen what the virtual registries do for you. And where I showed you an abstract virtual registry, now I can say that you can use Orca. And I would invite you to try it out. Orca is a free product. It has a premium tier, but we deliberately created a free product because we wanted to create some awareness on these challenges within the CI/CD world and artifact caching. So go to www.varnish-software.com/orca and give it a spin, give it a try. We also have a GitHub repo, not necessarily for the source code, but with documentation, tutorials, config files. So either go to the website, the landing page, or go to the GitHub site and figure it out, play around with it. We have some official Docker images. So it's as simple as taking this command, pasting it on your computer, and you can get started. Those examples you saw, what I did, time, docker pull, docker.localhost, well, those were done by simply spinning up this command. What this does is it creates a Docker container, exposes port 80 to your host system, calls the image Orca, and pulls from Varnish/Orca and runs a virtual registry on your system. I added -- platform Linux AMD 64 specifically for myself. I think others will have the same issue. I'm a Mac user. I'm using a recent Mac, and that's an ARM environment. And this image only has an AMD 64 environment for now, so you'll need to add that. So if you run it, you have it up and running on port 80. Yes, you can configure TLS. I'll show that later. If you're a Docker Compose person, it's as simple as throwing this in as a minimum config, running Docker Compose up, and you're good to go. Under the hood, within Orca, there's a config file. And that config file is based on our supervisor product, which is a way of deploying Varnish in an easier way. But we hide all the complexity behind Varnish. You can see that we're right now only exposing port 80. And then we have the virtual registry config setting with all the registries. That's how that works. This is not the exact file that comes as the factory setting, if you will, but it resembles that. So what we did, we were a bit opinionated and took a bunch of registries that a lot of people use and put them in there. And you give a registry a name, and that name, that key, as you can see, Docker Hub, npm.js, GHCR, Go, and many others, will be the subdomain that we match on. So you saw me do npm.js.localhost. Well, that matches that registry automatically. And yes, you could go further. It has Let's Encrypt support, and it allows you to generate self-site certificates if you want to, or you can map your own certificates. It's very easy to do so. And if you start extending the configuration and adding your registries, the ones that you use, then you can map it and mount it. So you could mount a custom configuration file into the container and add a config parameter, and all of a sudden your registries will be offloaded. It's as simple as that. All the complexities are hidden. And for Docker Compose, it's similar. You define a volume statement and a command statement, and you're off to the races. If you like Docker, but you want to orchestrate it in Kubernetes, worry not, we've got you covered. We also created a Helm chart that you can pull in over OCI from that same Docker Hub registry. Helm install Varnish Orca, OCI endpoint, ready to roll with the standard config. If you want to extend the config, there is a values.yaml file. You'll find the spec of that file on the GitHub repo or linked in the mini website, and you can mount it in and start configuring things. If you want to run it on bare metal or on a cloud instance or on a VM, we have Debian packages and we have RPM packages. You just install Varnish Supervisor because in the end, Orca is built on top of Varnish Enterprise and Varnish Supervisor. And let me remind you, it's free for public packages. So start using it. And once you're using it, then you can do stuff like this. Docker pull, docker.localhost. Now you know what that means. Docker.localhost, it matches the host name and it will take whatever registry is configured. It could be multiple registries with fallback or load balancing, you name it. If you want to install npm packages, you can point it to npm.js.localhost. Similar for Go, similar for Helm. Now let's land this proverbial plane. Because ladies and gentlemen, this is just the tip of the iceberg. I only have 45 minutes to talk about that, and I already went 2 minutes past my time. So just be aware that there's a lot more capabilities products in the pipeline. You'll see this product improve. We might figure out other products, and I encourage you to try it out. Go to varnishsoftware.com/orca, or if you want to look at the docs and approach from a more developer perspective, github.com/varnish/orca. And the final thing I want to tell you before we dive into Q&A, because I've already seen 3 questions pop up on the Q&A, is what about these other virtual registry capabilities like routing and security and observability? Well, I've got you covered there as well. The next webinar will be about that. And in conclusion, ladies and gentlemen, I love this meme. We can accelerate all the things. So that was it. Thank you for sticking around. I have 3 questions here, and if there's more questions, don't hesitate to ask me. Now, if you don't want to do it here, you think that question is kind of private, or you want to do it later, you can find me on LinkedIn or on other social media. My name is Thijs Feryn. Find me there. So, Maria, we have a couple one, right? So we have Patrick.
You do all the job. Yeah, I don't need to be here, even though.
Well, if you want to play along, you can do that. So Patrick asks, so I haven't prepared this, so I'm going to read it and then I'll have to think about an answer. So Patrick, what are your thoughts on running the GitHub in your DTAP K8S clusters? The runners just on D. That's a bit of a cryptic one. I think DTAP, you mean development, testing, acceptance, production, and the runner just on D. Patrick, I'm sorry, I would like to give you an answer, but I know what people typically will answer, and I'll do the same thing. I don't wish to insult you. It depends, right? That's the big consultant's going. If you're a consultant, you're always going to say, it depends. Yes, it depends, but I wouldn't mind running these in production, or you can split them up. I mean, we talk about CI/CD, and we use it casually, but there's a CI part, and there's a CD part. And the CD part, especially in Kubernetes cluster, in a lot of cases, is going to be Argo CD. You want to put that as close as possible to where you're deploying to. So I would put the GitHub runners themselves. Yeah, you can just run them on development, or you can even run them in production and use different namespaces. I don't care. But in the end, if we're talking about production grade stuff, just make sure the virtual registry is as close as possible. I would say virtual registry close to your CD. And then in terms of GitHub, I don't know, whatever suits your needs. I can't really answer that question right now with any confidence. What I would advise you, that's also the way out of these questions, is try it out yourself, find me and report back. And I will check internally, and I'll also see if we have experience with that question. So sorry for being so cryptic, Patrick. I wish I could have answered better, but it doesn't mean because I don't answer it fluently and smoothly now that I can't later. So if you want to discuss this, find me later. Next one, an anonymous person, a person that shall remain nameless. How is cache purging handled? What happens when the cache is full? Love that question. Love that question. You know why I love that question? Because I have the answer right at my fingertips. So I'm going to give you a very common one. And you don't need to answer it, because if you've been in IT for a while, you know it. So the quote by Phil Carlton is that there's only 2 hard things in IT. Number 1 is naming things, and the second one is cache invalidation. And the third one is off by 1 errors. So you probably get the joke, but I'm going to answer it. How does cache purging work? Well, in a typical cache like ours, that is, if you configure it memory-based, we have something called the LRU mechanism, least recently used. So what happens is, as you put things in the cache, we will create counters of the most popular content. And when the cache is full, we will need to drop something from the cache. And we'll do that based on the least recently used item. So the least popular item goes, it's gone. That is not a problem. You may think, oh, I'm losing that. Yeah, you only lose it from the cache. We are not a database. We're not a source of truth. So what will happen for that least popular piece of content is it will take a bit longer to fetch. But if you monitor that correctly using the observability tools that we offer, then you can get a pretty good grip on it, and maybe you can ensure that the cache size grows a bit. Maybe you will deduplicate that. Maybe you'll cluster it, have multiple caches to expand the size. That's the simple answer. The more in-depth answer would be, we can also offer within that Orca product, but that's part of the paid tier, unfortunately or fortunately, depending on how you look at it, we have something called MSE, which is an acronym that is short for Massive Storage Engine. And it's a super optimized disk and memory hybrid system. So what we do is we create memory allocations that you can configure and also provide a secondary sort of a fallback tier on disk. Now you think disks are slow. That's the bad rep they have. They tend to be slow because they're used that way. So what we're doing is we're not storing these in the files. We're creating pre-allocated large files that consume your entire data disk, and we have file system-like behavior on the inside. We've done benchmarks on a big rig, I must admit, and managed to get 800 gigs a second from disk. That's pretty fast. So the answer to your question is, if you don't want the memory to be recycled, your catalog is bigger than what fits in memory, instead of just scaling out nodes, you can add our massive storage engine to it and store terabytes, even petabytes on data, depending on the capabilities of the disk. So yes, there is persistence. You can enable it and it will work really well. We even created our own integration of the Linux page cache, because the Linux page cache is a generalistic system. It's not hyper optimized for our use case. So we also made sure that this is fast enough. If you get it from memory, Intel benchmarked us at 1.7 terabits per second on a single machine. So that is how we deal with caching. That is the sort of expiration and forced expiration. You also have, as you named it, cache purging, meaning deliberately removing items from the cache. You can do that if you want to. I wouldn't necessarily do it because most of the content is immutable. There is no real use in saying, oh, we need to remove that from the cache. If you need to remove something from the cache because it's getting quite full, it's probably because you didn't set the TTLs right or you just don't have enough storage. Yes, if you have like deliberate actions, if you would deliberately want to remove things from the cache, we have a pretty extensive catalog of invalidation tools that is either tag-based or URL-based. So we have got you covered. TLDR, thank you for your patience there, anonymous user. Yes, then Patrick again. In your example, you're doing a lot of work changing the Docker files. Wouldn't you want a pull-through registry kind of setup? Yes, we would like that. And I've had one slide on there that shows you how to do that from a Docker perspective. For Docker, you need to retag or have a pull-through cache. And I showed you one slide. Let's see if I could dig it up again. It's somewhere in the list. It's not too far off. Give me a second. I think this is the one, right? Registry mirrors on Docker is how you create a pull-through cache, and that's where you can put the endpoint, either the in-cluster one or from someone that is hosted or one that is hosted outside. So I agree with you. From a simplicity point of view and from a workflow point of view, these pull-through caches are a better idea. But if retagging is not a problem, retagging is simple. Then Patrick's back with a related question. Let's read it. Should I read it out loud, Maria? Probably, right? Make it easier. Related to the second question, it's more native to wherever the user is. You want to set things up, but you want to prevent the F-ups happening too easy, especially from a platform engineering perspective. So the system solves ghcr.io blah image to resolve the virtual registry, and it doesn't become a user problem. Yeah, absolutely. And I mean, we've just created Orca in a way where you just use a subdomain and pull it through, but I'm pretty sure we can also extend that configuration and abstract the complexity even more for your users, where maybe you can set more business rules in that virtual registry YAML config to create more things that tailor your needs and to do that. If you have ideas, Patrick, on like, I would encourage you to use Orca for free and just try it out. If you have feedback of that kind from a platform engineering perspective or feature requests, reach out to me directly or on the GitHub repo that I shared. You can log an issue and we would be happy to look into it. I mean, it's early days for this project. We could use some users. Then an anonymous user, you said it's free for public registry. How does it work for private ones? Is there a payment mode? Yes, there is. We're all figuring this out on the go, right? This use case, I've mentioned the timeline. Since 2024, we've been working on this, but we've only called it Orca for, let's say, 3 weeks. So it's very young, and we've figured out pricing. And for now, you can reach out to us. On the Orca website, there is a way of getting a free trial license for the full shebang with all the features and all the bells and whistles on it. And that's also the way you can get in touch with us. So if you want to try it out for private packages, you'll get a free trial, no questions asked. It will automatically send you an email with a license code and a tutorial on how to deploy the license in the config. And I'm not sure if it's 30 days, but you can play around with it and see the value. And if you're interested in buying, then you can easily reach out to us. Is there HA available for the cache? Is another anonymous user's question. How is the cache distributed across Orca pods? Well, we have a built-in clustering system. So if you have multiple instances of the artifact cache, we have an internal component that does this clustering. So what it does is, using an algorithm, it figures out who it considers the primary. And only the primary talks to your origin to avoid overloading. And the other ones fetch it from there. So it's like your typical sharding story where content automatically gets distributed and you could choose how many replicas it has. I'm not sure to what extent all of these capabilities are exposed in the YAML file, but it's definitely there. We have it. And out of the box, we use fallback mechanisms. If you deploy multiple registries under a single key name, it will use a fallback pattern, but you can reconfigure it and then use hashing as well to have HA and clustering. And then the last one, thank you for sticking around. We're almost an hour into this. Can Varnish synchronize with the registry? Well, it can, but should it really? I mean, I've pre-warming the cache is an item that I've seen before, and we've looked into it for most of our clients. This is not unique to artifacts. This is just the way of caches in general. And we've usually advised against that, because all of a sudden you'll have to do a lot of heavy lifting and pulling things over the network for registries that might never be consumed. So the way we do it is we just wait until requests come in. Because what's the worst thing that can happen? You'll have the same quality of experience as pulling it from the registry directly. If you do have predictions, or or you want to measure what's going to be popular, you can do pre-fetches if you want to. It's a possibility. But generally, I would advise against having a one-to-one sync. There's one exception, though, that we've seen is when we deploy Git mirror or using Git, we can deploy a Git mirror very close to the cache and fetch it from there to reduce the latency. That's the only type of synchronization that I would see. And I hope, dear people who ask the questions, that this fully satisfies your needs. And if it doesn't, find me. I'm not afraid of facing you. I'm not afraid of owning up to it. And I'm also not afraid to say, sorry, I don't know the answer, but let me find someone who will. And that concludes it. We're 1 hour into this one. So thank you for all of those who stuck around. And thanks to those audience members from the future who will be watching this later on, either, I don't know where, probably on YouTube, right?
Yeah, we are live on YouTube. Thank
That's all
you
I have.
to you, Thijs. It was amazing. Thank you for hosting such an amazing presentation. I loved being on the spot and showing my math skills.
Yeah, your math skills. So what's 5 times 3 times 4?
Yeah, 60.
60, great.
Now it's less than 1 second. But yeah, also like check out, we'll share the blog post also from Thijs later on. And as we mentioned in the beginning, we'll share the recording and slides. So if you guys want to reshare it with your colleagues, it's totally possible. Also, Thijs, you're on the platform engineering Slack, right? So if
I think I am, yes. Well, my manager has encouraged me to do it. So if I haven't, it's part of my to-do list to go on there as quickly as possible. So yeah, if we talk about a quick way of interacting with me, it's probably there as well. So I'll make a mental note and make sure I'm on it ASAP.
Amazing. Well, thank you so much to you, first of all. Thank you so much to everyone who joined. Happy Thanksgiving to our US colleagues early on. I know it's a big holiday for you, and probably like most of you will already start celebrating tomorrow. So thank you for joining today, if you do. And this was a great presentation. So hope to see you at the next one.